Okay, so this next problem is going to be an Atwood machine problem. So in this problem, we have basically a pulley and two masses hanging over that pulley, mass A and mass B. We're going to say that mass A is equal to 2 kilos. We're going to say that mass B is equal to 3 kilos. Now, our objective in this problem is to say, hey, there's the string there, or the rope. What's the tension in it? That's our question. Now, in order to find this, we can't solve this unless we first have to find the acceleration. If we find the acceleration, then we can find t. Okay? In order to do this, this is actually a new class of problem where we have to analyze this in terms of dynamics in two different ways. The first way, which is why we have to find A, is we're going to say this is a system. And we know that B is heavier, and we know that B is going down. So what we're going to do is we're going to say that we have a positive direction as a path. Okay? So positive direction is a path. That's the most important new concept here. Okay? And what is that path? Well, it goes up here on this side and down on this side. That means that now if we do summation, okay, of our forces on the system, that's going to equal F net of the system. Okay? So we've done summation of the forces equal to F net before, but we've just never done it for an entire system. Okay? So let's now put on our forces here. There's going to be a force there. We'll call that MAG, and we'll call this another force going down here. We'll call this MBG. Okay? That's not the only forces, because, of course, in order to do a free body diagram here, we have to say what's touching it plus gravity. Well, the thing that's touching A is the rope. And we know that ropes can only pull, so we have a tension here. And the same thing for B. We know that the rope is pulling up on B, so we have a tension here. In fact, that's what we're trying to solve. But there is one thing that I haven't told you yet, which I'm going to write down here, and that is, this is kind of like a new magic sentence. One rope can only have one tension. So it's not possible for one rope to have two different tensions in it. Now what that means is that this tension here is going to be the same as that tension there. Okay? So let's go ahead and now complete this equation here, understanding that this tension is equal to that one. But you see, what's different about it is that on this side, on A's side, you see, up is positive, but on this side, on the B side, down is positive. Okay? Because we've chosen this path. And how do we choose that path? Well, because we know that A is going to be going up in this problem and B is going to be going down from life experience. B is heavier. B is 3, okay, and 3 is more than 2. So yeah, A is going to go up, B is going to go down. So let's continue to write our equations here. So in this case, MAG is negative. So we're going to have negative MAG. Positive T, which is this T here, okay? And then a negative T for the next one, which is that one. So that's going to be negative T, okay? So this T is the first T is associated with A, and the second T is associated with B. Do you notice, though, that they're actually mathematically canceling each other out? The reason for that is because it's an internal force on the system. In other words, if you consider not just A and B alone, but the whole thing as a system, well, this tension now becomes an internal force, and an internal force cancels itself out, as we have just proven here. Now, but there's one more force which we haven't yet drawn, and that is plus mbg. Okay? So once again, this force is negative. Okay? This force is positive. This force is negative, and this one is positive again. Why? Because of the direction of our path. I hope that's clear. Now, we say that's equal to F net of the system. But we know that F net, right, from second law, F net equals ma. But in this case, it's F net of the system. And that means it's the mass of the system times the acceleration of the system. Okay, so where does this get to? Well, we can cancel out these t's. They cancel each other out, and we're left with mag negative here and mbg here. But we can factor out a g, and we can rewrite it as mb minus ma times g. Okay, so I just factored out a g. And now that's going to equal the mass of the system. What is the mass of the system? Well, there's only two masses in the system. It's ma plus mb. Okay, times an acceleration of the system. And so now to find the acceleration of the system, all we would do is we would just take this term and put it in the denominator on the other side. So it would be this term divided by ma plus mb, and that's all going to be the acceleration of the system. Now if we stick our numbers in, that's simply going to be, 3 kilos minus 2 kilos times g divided by 3 plus 2 being 5 kilos. Okay? And in effect, we end up with 3 minus 2 is 1. 1 over 5 is 1/5, which I think is 0.2. So we end up with 0.2 g. Now, we know the acceleration of the system. Question is, which mass does this apply to? Well, let me draw the picture again. The one up there is a little bit getting messy. So if I draw it again, what this means is that this mass is accelerating up at 0.2 g, and this mass is accelerating down at 0.2 g. The accelerations must be the same, or else the rope would have to stretch. They're connected to each other. Okay, now that we know the acceleration of each mass, we can now find the tension simply by doing a free body diagram, not on the system now, but on one of the masses. So if I change my color here, and I say, all right, we've got a tension acting up. Let's just pick, for simplicity's sake, it doesn't really matter which one you pick at this point. Let's pick B. I've got mbg going down, force of gravity, right? And tension going up. So now if I do my, let's just draw a line here and we say, okay, let's do summation of the forces now is equal to F net, not on the system. Now we're just considering B. Okay? We'll say, all right, which way is positive here? Don't forget, don't change this. Okay? Yeah, I know we picked a path before, but I'd like to stay with the direction on the right-hand side that we had before. So I'm going to say positive is down. So that means we're going to have mbg minus t equaling F net, which is ma. Okay, and that's a B. So in order to solve for t, we're going to go t is equal to mbg minus mba. And we can do a little bit of factoring out of that as well. Or actually, yeah, sure, we can take out mb, and we can say it's just g minus a. And, but the nice thing now is that we know what a is, you see, because a was already discovered previously. Okay, so we can say, finishing it off, we can say T equals mbg minus 0.2g, and lo and behold, what do we get? Well, that's just, 1 minus 0.2 times g, and so that's just 0.8. Answer for the tension, 0.8 mbg. And the rest is trivial, right? Because it's just MB we know is 3 kilos, and G is 9.8 newtons per kilo. You do the multiplication, and you get 0.8, enter, 3 times, 9.8 times, answer 23.5 newtons. And we're done. And we could have easily also, we could have easily gotten the same answer, by the way, using A. Up to you which one you want to do. It would have been very, very similar calculations. Thanks for watching.